Okay, I'm on page 280 in your textbook, section 4.6, titled Inverse Trigonometric Functions. So before we get into the inverse trig functions, I want to talk about and remind you about inverses in particular, okay? Here I have a parabola, and by definition that parabola is a function because everywhere it passes the vertical line test, okay? But when I look at that parabola fails the horizontal line test, so although it has a function, if I were to go graph its function would look like this. It reflects across that line, y equals x. So it does have an inverse, but its inverse is not a function because when I draw it, it flunks the vertical line test. So if I were to take and rotate this parabola back up to where it stands up, it would have originally failed the horizontal line test. So if something fails the horizontal line test, it does not have an inverse that is going to be defined as a function, okay? Right? So I want to look at a normal sine curve, okay? So I've kind of got a little jump start here. So I'm going to draw a sine curve, and my sine curve starts at 0, goes to 1 at pi halves, comes back to 0 at pi, goes to negative 1 at 3 pi halves, and comes back up to 0 at 2 pi. So here is one wave of my sine curve. So if I go clockwise, at negative pi halves, it would be at negative 1. At negative pi, it would come back up to 0. At negative 3 pi halves, it would be at 1. And back at negative 2 pi, that would give me a second wave of that tangent curve, okay? So by definition, of that sine curve. So by definition, that sine curve is a function because it passes the vertical line test everywhere. But if I draw a horizontal line that would shoot through there everywhere, it would cross multiple times at each one of those so-called gumdrops of that sine curve, okay? So I know by looking at my calculator that I have an inverse sine function, inverse cosine function, and inverse tan function. Those are the blue symbols right above those cosine, sine, and tan buttons, which you learned in geometry enabled you to go find angles, okay? So anytime you do an inverse, the inverse is to go find angles, okay? So what I'm going to do is I'm going to take out part of this curve. I'm going to take out that portion of that curve right there. And then I'm going to take out this portion of this curve right here. So when I take out that portion of the curve, then I have a piece of the curve that can be defined to have an inverse that is a function. So the piece of the curve that's left is at negative pi halves, and it's up here at pi halves, okay? So each one of these dots, I have 3 dots. I'm going from the top to the bottom. I don't know if you see me tracing those or not, but each one of those dots have an ordered pair. So that first dot right here, this first dot right here has an ordered pair that is pi halves, in normal sine that is pi halves and 1, okay? All right, right there at the origin, it has an ordered pair that is 0, 0. And then this ordered pair right here is negative pi halves and negative 1. That is negative pi halves and negative 1. All right, so an inverse is going to exist here. So the inverse is going to be interchanging my x and y values. So my inverse here would be, this ordered pair would be 1 and pi halves. All I'm doing is switching the order from here to there. This one would stay at 0, 0. In other words, there is a switch, but it's the same. And this one is minus 1 and minus pi halves. So if I were to go graph this inverse function would look like this. I have 1 to the right, I have negative 1 to the left, I have pi halves that's going up, and I have pi halves, negative pi halves that's going down. So the x and y values have changed. So if I go graph the inverse ordered pairs in this column, I go over 1 and I go up pi halves. 0, 0 on here, I go left negative 1 and I go down pi halves. So here's the curve right there for the inverse sine function, okay? So the inverse sine function is defined between negative 1 and 1. Remember that the inverse sine or angles are found to exist that have a sine value to be negative 1 and 1, okay? So when I look at this graph, this piece of this graph right here, that's quadrant 1. This piece of this graph right here, that's quadrant 4. So when I go look at my inverse sine function takes place in quadrant 1, and it takes place in quadrant 4. Positive values for sine will be in the first quadrant, negative values for sine will be in the fourth quadrant. And the only way that I can move to get in those quadrants off the positive x-axis is I move counterclockwise. I don't go anywhere past pi halves, and I go clockwise, and I don't go past negative pi halves. So I'm relegated to pi halves up here, and I'm relegated to negative pi halves down here, so I'm in this semicircle right there to be able to define the inverse sine, okay? Now, the sine of any angle, here's a repeat, the sine of any angle will always fall between negative 1 and 1, okay? All right, so now we come to page 281, and we're going to look at some example problems. Now, anytime you see inverse sine or you see arc sine, they mean the same thing because angles and arcs given on the unit circle have equivalent radian measures. Therefore, that inverse sine is also sometimes referred to as arc sine. They're both asking you the same thing. And anytime you see inverse sine or arc sine, that tells you that you can go construct a triangle. You can always construct a triangle on any of these three example problems that we're looking at, okay? All right, so here, I'm asked to go find an angle whose sine is 1/2. That's red, inverse sine of 1/2, but it's asking me to find the angle whose sine is 1/2. Now, those of you that really know your unit circle well, you know that this ordered pair right here is the square root of 3 over 2, and it's 1/2, and you know that that angle right there is pi 6. So your answer there would be pi 6, okay? All right, now I told you that we should be able to go draw a triangle, okay? So this is for the person that knows their unit circle, okay? Watch the same problem, and I'm going to go construct a triangle because I'm able to do that because I'm doing inverse sine. So I'm going to go draw the triangle, and I'm going to go draw it in quadrant 1 because that value right there is positive. And that's the value of y. That's the value of y, which is 1, over the hypotenuse, which is 2. And those of you that know your 30, 60, 90 triangles really well from from geometry and algebra 2, you know that that's a 30, 60, 90 triangle, and the 30-degree angle is across from the side 1. And 30 degrees in radian measure is equivalent to pi over 6, okay? All right, moving to example 1b. Now, once again, I'm asked to find the arc sine of negative square root of 2 over 2. So that's asking me to find an angle whose sine is going to be negative square root of 2 over 2. Now, for those of you that know your unit circle real well, you know that I'm down here in quadrant 4 first off because that's a negative value for that I'm finding of arc sine. And that splits that quadrant right in half. That ordered pair is the square root of 2 over 2 and minus the square root of 2 over 2. And I told you that in these arc sine problems, you're either going to move counterclockwise or you're going to move clockwise. So here I choose to move clockwise, and the size of that angle is negative pi fourths. That angle is negative pi fourths that has a sine to be negative square root of 2 over 2. Okay, so you've got that, and you can always rewind this if you need to. But I'm going to go now, and I'm going to go construct a triangle. Well, I think this one would be more confusing if we construct a triangle on that one because it's, the square root of 2 over 2. I mean, we all know that one. I don't think we need to do that, okay? So to get back to that one, let's go back and put that angle right there. That angle is minus pi over 4, okay? All right? So when I look at, well, you know what? We could construct a triangle. Watch this. We could do this. It's not a big deal. Okay, we could construct a triangle by putting all of that over 1, okay? So I'm going to go down the square minus the square root of 2 over 2, and I'm going to go 1 right here. That's 1. So this is the square root of 2 over 2, and sure enough, that's that ordered pair, square root of 2 over 2, and minus the square root of 2 over 2, which gives me that angle to be negative pi 4. So we could do that, so it's not that big a deal, okay? All right, so this one. Now, for those people that take good notes and you listen really well and you retain what you've learned, I already know that the sine of any angle has to fall between negative 1 and 1, so this problem right here is not possible because 3 is out of the domain of where the sine can be found. So let's pretend like we don't see that, and we're going to go try to draw this triangle. Well, I'm going to draw it in quadrant 1 because 3 is positive, and that's 3 over 1, so that's y over the hypotenuse. So I'm going to draw 3 as my y value. There's my hypotenuse of 1. You can't do that. There's no way it can be drawn. If it cannot be drawn, the triangle does not exist, okay? All right, here's some extra sine problems. I'm going to go find the arc sine of the square root of 3 over 2. Now, this one is derived from people that know their unit circle. So I've got my unit circle memorized. I didn't learn it just to make a good score on the quiz. And this ordered pair over here is 1/2 and the square root of 3 over 2. So that angle right there is pi thirds. So So the people that know their unit circle are going to perform really well on this, okay? All right here, I'm not sure about that. I know that that's negative 6.28. That's the value of negative 2 pi. So those that listen really well, you know that that's not possible because the sign has to fall between negative 1 and 1. Okay, so let's pretend like we don't know that. Let's go try to draw a triangle. Now that's over 1 and it's negative. So I'm going to come down here, negative 6.28, and I'm going to put it over 1. Well, that can't be done. And if the triangle can't be drawn, then the angle does not exist. Okay? All right, here's another one. The arc sine of negative 1. All right, so I know I've got to be in this quadrant right here. Well, I'm right on that angle. That's 0 minus 1 half. 0 minus 1. So the angle is right there, and that angle is negative pi halves. So the angle whose sine is negative 1 is negative pi halves. Okay? All right, that brings us to cosine. Okay? Here's my normal cosine curve. Now, once again, the normal cosine curve, by definition, is a function because it passes the vertical line test everywhere. But if I come across right here and I draw a straight line all the way across, it's going to hit in multiple spots on those upward gumdrops, so it's not going to be defined for its inverse to be a function also, okay? But if I go snip, if I go take my scissors and cut this right here and cut this right here, and I erase everything else is going to go. If I erase everything else on that graph, take it out, and I go look at that portion of the cosine curve, that portion would pass both the vertical and the horizontal line test. So where am I? I'm between 0 and I'm between pi. So I'm actually in, this right here represents quadrant 1, and this right here represents quadrant 2, okay? So the inverse cosine occurs in quadrants 1 and in quadrants 2, okay? So if I go give the ordered pairs for what I see right now, I would say, okay, that ordered pair is 0, 1, 0, 1 straight up, so the inverse would be 1, 0, okay? This ordered pair right here, this one right here is pi halves 0 on the normal curve. It's pi halves 0, so over here it would be 0 pi halves. This ordered pair right here is pi negative 1. That's pi negative 1, so over here it would be negative 1 and pi, okay? So if I were to go sketch this is now going to be 1, this is going to be minus 1, and I'm going to be up here at pi and there at 0, okay? So I'm going to go graph these ordered pairs. So I go over 1, 0, I'm right there. 0 pi halves is right there. And negative 1 pi is right there. There's the portion of the curve that represents the inverse cosine, okay? That's the inverse cosine curve. That is the inverse cosine curve right there, and that can also be written as the arc cosine of x. They mean the same thing, okay? All right, so now we come to inverse cosine. So inverse cosine takes place in quadrants 1, where your x values are positive, and quadrants 2, where your x values are negative, okay? And then once again, I have it written as an inverse, and I have it written as an arc cosine, okay? And the same thing that held true for sine is also going to hold true for cosine. You have to stay in that domain to be able to define an angle, or to find the sine of a cosine of an angle, okay? All right, so here comes some cosine problems. I'm on page 282, looking at example 2a. This tells me to find an angle whose cosine is negative square root of 2 over 2. All right, so I know that it splits this quadrant right here, and I know that that's minus the square root of 2 over 2, and that's the square root of 2 over 2 from my unit circle, and I know that that angle right there is 3 pi fourths, and we're done, okay? Now, I could also say 135 degrees. I'm just starting to think in terms of radians, because that's typically what you're going to use in a calculus setting, okay? All right, so let's go down here. Example 2b, looking at arc cosine of negative 2. We're still on page 282. And I already know that this is not possible because I took some really good notes, and I know that that falls out of the domain from negative 1 to 1, so that can't occur. Well, what if someone's not listening and they need to go draw this? So I know I'm going to be in quadrant 2 because the cosine is negative, and that's understood to be x over r. So I'm going to come over here and I'm going to move negative 2 to the left, and I got to put it over a radius of 1. Well, that can't happen. You can't have a leg that's longer in length than the hypotenuse. So if you can't draw it, it doesn't exist. You're done, okay? All right, right here, example 2c. I want to find an angle whose cosine is 0. Well, I know my unit circle, that's 0, 1 right there, and I'm still in this semicircle, so the angle that I look at that has a cosine of 0, that is pi halves, and as a degree measure, that would be 90 degrees, okay? All right, so here's some extra problems on cosine. All right, so I know my unit circle, and I know that that's this ordered pair right here. This is minus the square root of 3 over 2, and it is 1/2. And I know that that angle right there is a radian. That's 5 pi 6, okay? And as a degree, that would be 150 degrees, okay? That's an angle whose cosine, this is red, inverse cosine of negative square root of 3 over 2, but it means to go find an angle, go find the angle that has a cosine to be minus the square root of 3 over 2, okay? All right, right here, once again, I'm in quadrant 2, and I want to go find an angle. I want to go find an angle whose cosine is negative 1/2, okay? An angle whose cosine is negative 1/2. Well, once again, I know my unit circle, and that ordered pair right there is negative 1/2, and the square root of 3 over 2, and that angle there is 2 pi thirds, okay? So the person that really knows the unit circle, you're going to have a field day on this. People that don't know their unit circles, this is going to give you some level of difficulty, okay? All right, now we're going to look at the tan function, okay? Now the tan function, we're on page 283. The tan function, there's 3 normal curves right there, and the 3 waves of the tan function. And if I were to go draw a straight line straight across through there, it's going to hit 3 times and multiple times because it goes on for infinity. So it's not defined where its inverse will be a function. But if I take out this curve, and I take out this curve over here, and I relegate myself between negative pi halves and pi halves, then I have a piece of the curve that will have an inverse that is defined to be a function, okay? So here's some normal points. Normal points would be pi force and 1. 0, 0 on the normal curve, and then negative pi force and negative 1, okay? So over here, the inverse function would be 1 and pi force. It would be 0 and 0, and it would be negative 1 and negative pi force, okay? So if I were to sketch this, on the tan function, I would be at pi halves up. I would be at pi halves up because that's an asymptote. And I would be at pi halves down because that's an asymptote. And I would have ordered pairs to be 1 and negative 1, okay? So I'm at 0. So I'm graphing these points right here. So I go over pi and up pi force. I go I go over 1 and up pi force. I go left 1 and down pi force. So this curve looks like that right there, and it goes on and on forever and ever and ever. So the difference here is that the normal tangent curve had asymptotes that the sine and cosine curve did not have, okay? So to look at the tangent function is much like the sine. Okay, it's just like the sine function. We're relegated to quadrant 1, where tan values are positive, and we're in quadrant 4, where tan values are negative. Okay, and then once again, I can read it as the inverse tan, or I can read it as the arctan. Okay. So I'm on page 283, and we're going to look at some tangent problems. Okay. Now here's where I'm going to erase this one in a minute and show you a different way to find this. Okay. So I know that this ordered pair right here, and it's because I've used it so much. This is 1/2, and this is the square root of 3 over 2. So if I do the tangent is the sine. It is the sine over the cosine, and that gives me the square root of 3. Okay. So I know just from experience of the unit circle that answer right there is pi thirds. Okay. And once again, the calibration is off on this, so please forgive the erratic marks on this on the screen. Okay. All right, so I know that answer is pi thirds. All right, so let's pretend like we don't know that very well, okay? Let's say you don't have that unit circle down that good, okay? So let's go and graph this. That's square root of 3 over 1. So that's the square root of 3, and that's 1 by definition of the tangent curve, okay? All right, so I know from geometry that that's the ratio of a 30, 60, 90 triangle, where 60 degrees is across from that longest leg. So that has to be 60 degrees, which in turn is pi thirds, okay? All right, the arctangent of 0. Okay, so on my graph, this is where 0 occurs. I have 1, 0, and once again, that's sine over cosine, so the answer there is 0. Okay? All right, now, this next one, we got to get a little bit creative. If I go draw a triangle with minus the square root of 3, I mean, check this out. If I go draw a triangle that's minus the square root of 3, and it's 3 right there, that means nothing to me, okay? That doesn't do anything for me in terms of knowing what the ratio of the sides are. So what I'm going to look at this is I'm going to look at it in this light. Where did this right here come from before it was rationalized? Well, it came from 1 over the square root of 3. If I rationalize this, it looks like that. So I got to be able to reverse the process and understand where negative square root of 3 over 3 came from before it was rationalized. Now I can go draw this thing, okay? Now I can go draw it, and I have it drawn as this is the square root of 3, this is minus the square root of 3, and this is 1. So sure enough, the tangent of that angle, I've got it backwards, hold on. If I want to draw it, I need to draw it right, okay? So when I go draw this, it is 1 minus 1, and that's the square root of 3, so there's your angle right there. Okay, and when I go look at that angle, as I move down in this direction, that is minus pi 6, so the answer to this problem is minus pi 6, and we're done, okay? All right, I want you to look on page 284, and I'm going to tell you right now, this is going to be a calculator-based problem, okay? I'm going to expect you to just do this with a calculator. So you would just go put this in the calculator, and you would put it in like this. And y sub 1, you would hit the inverse cosine button and put in 2x, and that would graph the graph that you see. Now you need to adjust your window. So your window for x maximum needs to go to 1, minimum needs to go to negative 1, and then your y values need to go from 0 all the way up to pi, and it would graph it. So, but I'm going to show you what the author has done. Okay, this y equals arc cosine of x in this box right here, in that box, translates to cosine y equals 2x, because it's the cosine of the angle is equal to 2x. This says to find an angle whose cosine is 2x. Well, the angle is y. So the cosine of y is equal to 2x, and when I divide both sides by 2, I get this as my value for x. Now in an xy chart, there's my x values, there's my y values right there, okay? So my y values, I'm using what is in my rotation. I'm using what is in the rotation in the first quadrant. So I go from 0, there's from 0, out to pi, and that's moving right here in the first and second quadrant. So if I take 0 and I insert it right there in y's place, the cosine of 0 is 1 times 1/2 is 1/2. The cosine of pi fourths is the square root of 2 over 2 times 1/2 is the square root of 2 over 4. The square root of pi, and so we go on and we fill out all these boxes that you can see filled out there on page 284, but I think you can do this in a calculator, and this is what your graph would look like right here when you put this equation right here, well actually right here in your calculator, okay? All right, I'm on page 285, and for second and third period, I don't think I got to this, so here's this movie screen problem. Here's what it says. A person's in a theater, and their head is right there at the tip, at the vertices of that triangle. This D right here is the distance of the ground level of those triangles, okay? And I'm going to tell you that this angle that I'm coloring in here right now, that angle right there is theta 1, okay? So there's theta 1 right there, it's that small angle, okay? All of this angle right here, we're going to call that theta 2. So, but what I want to find is the best angle, and the best distance for me to view that screen in the movie theater. Now the screen goes from this dot here to that dot right there. Now this is definitely not drawn to scale, okay? So that red theta is equal to theta 2 minus theta 1, okay? All right, so what I'm going to do is, and you can see the dimensions on page 285, where it tells you that the person's head is right here, and it's looking up at that angle. So this distance from here to here is 4. So that total distance of that big triangle is 36. And the total distance of this little triangle right here is 4. So I can set up a tangent relationship. So the tangent of theta 1 is equal to 4 over that distance d. The tangent of theta 2 is equal to 32 plus 4 is 36 over d, okay? So now these are inverse tans. So theta 1 is equal to the inverse tangent of 4 over d, and theta 2 is equal to the inverse tangent of 36d, okay? Now we said right here that theta is equal to theta 2 minus theta 1. So if I take theta 2, which is tangent of 36 over d, and I subtract inverse tangent of 4 over d, if I go graph that, I can find that maximum distance, okay? So what I've done is I've already gone ahead and put this in, let me see if I can pull up the calculator. I've already got this pulled up in the calculator, and what I did is I went to y equals, and I put that equation in. That's inverse tangent of 36 over x minus inverse tangent of 4 over x, and I've adjusted the window where I went on my x values from 0 out to 100 in a scale of 5, and my y values from 0 up to 70 in a scale of 5. And then when I went and graphed this, there's the graph that represents the difference of the theta 2 and theta 1, okay? So for me to find that maximum, I'm going to hit second calc. I want the maximum, which is number 4, and I'm going to trace. I'm going to go over here, and let's see, I'm going to get over here and trace. Got to go find the maximum, so I'm going to get over here. It won't let me do it like that. I got to keep hitting it. So I'm going to get on the left-hand side, hit enter. Now I'm going to come back on the right-hand side. And on the right-hand side, hit enter and hit enter again. And hit enter again. And it shows you it's about 12 feet, okay? So your distance is about 12 feet. So you have to be about 12 feet to get the best angle of looking at that screen, okay? All right. All right, now I'm on page 286, and we're going to look at compositions of functions, okay? Now, I will tell you that in that gray box on page 286, there's a key concept that I'm looking at, there's two columns, okay? There's f of inverse of x, and then there's f of inverse of f of x in two columns. I should have put a line straight between those. So I'm looking at the column on the left, and it says the sine of the inverse sine of x is x. Then the second one says the cosine of the inverse cosine of x is x, and it says the same thing for tangent. On the other side, we swap the inverse and the sine. So it says the inverse sine of the sine of x is x, and it goes through and says the same thing for cosine and tangent. Now, if you want to, you can go memorize that stuff. And if you memorize that stuff, you can probably get some problems right, but you're not going to get all problems right, okay? And here's why. Watch this. When I look at this one right here, well, I go to column 1, and I look at sine, and it says the sine of the inverse sine of x should be equal to x. So that problem should be negative 1/4, okay? But I'm going to verify it with a triangle. So this right here tells me to go draw a triangle. Anytime you see arc sine or inverse sine, go draw a triangle. So I'm in quadrant 4 because that's negative. Don't forget that inverse sine is in quadrants 1 and 4. So I'm going to draw a triangle, and the triangle is like this. It is 1, and that's 4 right there. So that's negative 1, and that's 4. So there's an angle whose sine right here is negative 1/4. Okay, then it tells me when I go on, so that's the inside. When I go on the outside, it says, okay, go find the sine of that triangle. Well, the sine of that triangle is negative 1/4, and sure enough, the key concept worked really nicely there, okay? All right, now, when I look at this one, example 6b, that looks like the arc tangent. So that looks like the second column, the third one at the bottom in the key concept box, and it says the inverse tangent of x should equal to x. So if I just say that the answer there is pi halves, I'm going to miss that, and here's why. Watch this. When I go to an angle right here, this tells me right here to just go find the value at that angle, okay? So I'm going to go up to pi halves, and I'm going to find the value. So this means value. That means value, and this over here means triangle. So this over here is going to mean value on this one, okay? Because you're looking at the sine of a particular angle. So the value of that is going to be 0, 1, and the tangent of 0, 1 at pi halves is undefined. So if this is undefined at pi halves, then you can't find the arctangent of that, and you're done, okay? All right, so check this one out. 7 pi 4, sine of 7 pi fourths. Well, the sine of 7 pi fourths comes around here, and And that ordered pair that I've got memorized from the unit circle is minus the square root of 2 over 2. So that's what I'm going and looking for. I'm going looking for a value. Now I need a little work room over here, so I'm going to take this out so I can have some work room. I need to show you this, okay? All right, so I went and found the value. So in other words, now I'm really finding this problem right here. I'm finding the arc sine of negative square root of 2 over 2. So that's asking me to find the arc sine. Well, the arc sine takes place in quadrants 1 or in quadrants 4, and I only have two different ways that I can move. I can move in this direction, or I can move in that direction. Well, I definitely want to move right here. That's what I want to look at, and that angle right there is negative pi fourths. Okay? The angle is negative pi fourths, and we're done. Okay? All right, here's some more. I want to find the cosine of the arc tangent of negative 3/4. Okay, so look here. That tells me to go draw a triangle. Okay, so I'm going to go draw the triangle, and I'm drawing it down in quadrant 4 because tangent inverse tan takes place in quadrants 1 or 4. Okay, so this tells me that this is coming down negative 3. That's 4, and I draw my hypotenuse. Sure enough, that angle coming right here has a tangent to be negative 3/4. Well, this triangle right here is a Pythagorean triple. So that I know that that's 5. Okay, so now the problem is this. Go find the cosine of the triangle. Well, the cosine of the triangle is 4/5, and you're done. That's it. Okay? All right, the next one, if you go read the problem in example 8, it says to go find an algebraic expression for this. Okay? So once again, this is telling me to go draw a triangle. So I'm going to go draw the triangle. And this time I'm in quadrant 1. Okay? So this is A, and this is 1, because that's A over 1, and the sine is defined to be y over r, okay? So now I've got to find the length of this leg. So the length of this leg, taking the Pythagorean theorem backwards, that's the hypotenuse square, which is 1, minus the other leg square, which is a square. Now I want to go find an algebraic expression that's going to represent the tangent of that triangle, because I've already got the triangle. So the tangent is going to be a over the square root of 1 minus a square, and if I go rationalize that by multiplying by 1 over a square times 1 over a square, that's going to give me a on the square root of 1 minus a square all over 1 minus a square, and you're done. That's it. Okay? So that's your inverse trig functions. Okay? Hope this helps you. Got any questions? Get to tutoring.